Okay, so we've just said that more reactive metals are able to displace less reactive metals, and less reactive metals are unable to displace more reactive metals. Okay, and what that means is we can now put metals in order. So we've seen this before a little bit, and we'll see it again now. They can be put in order of reactivity, and we call this a reactivity series. Okay, so this isn't all of the metals, this is just some metals, so there will be other metals in here that are even more reactive or even less reactive. But we have up here, these are our most reactive, and these are our least reactive. Okay, unsurprisingly, things like copper, silver, and gold down here, not very reactive. Now, we can say that if I have a reaction between metal A and a compound of metal B, if A is more reactive than B, it will displace it. Okay, so if A is more reactive than B, it will displace B. Okay, so if I was to do a reaction of magnesium with a compound of lead, then my magnesium will displace my lead. If I was to do a reaction of iron with a compound of silver, the iron will displace the silver. However, if I was to do a reaction of copper with a compound of zinc, okay, copper is below zinc in the reactivity series, so copper cannot displace zinc. Okay, right, so we just need to do a couple more examples. So in the last video you saw these examples were when we had a metal reacting with a solution. So the metal displaces the other metal from the solution. All right, now that won't always be the case, so we can have this reaction here. All right, and this reaction is known as the thermite reaction. Okay, so if we look carefully at this, we've got aluminium metal reacting with iron oxide to give us aluminium oxide and iron. Now this reaction is not balanced, so you need to balance it now. So pause the video and balance it. Okay, so you should have over here, we've got 1 aluminium plus 2 irons and 3 oxygens. Gives us 2 aluminiums and 3 oxygens plus our iron. So we can see straight away that our oxygens are fine, but I've got 2 aluminiums here and I've only got 1 here, so I need another one there. And I've got 2 irons here, only 1 over here, so I add that one there. So the balanced equation will be 2 aluminium. Now that's solid, so we're adding solid aluminium metal to my iron oxide, which is also a solid, so that's solid iron oxide, and I get 1 aluminium oxide, also a solid, plus 2 iron. Now you should have noticed up here that the state symbol for iron is L, which means that we have liquid iron, which should give you an idea of how hot this reaction gets. So I add solid aluminium to solid iron oxide, and I get aluminium oxide and liquid iron. So the reaction is so hot that it produces liquid iron metal. All right. Now, in terms of displacement, the exact same thing is happening. Look, so I have aluminium here and iron here. And if I go back to my reactivity series, okay, I can see that aluminium is above iron in the reactivity series. So aluminium will be able to displace iron. So the aluminium displaces the iron. To give me aluminium oxide and my iron left over. And again, the reaction is so hot that it doesn't produce solid iron metal, it produces liquid iron metal. Okay, it's an extremely hot reaction. So if we do one more example, so this is equation number 6 for today. Let's do iron plus copper oxide. Okay, and I want you to decide, is it going to displace it? So will iron displace copper? Okay. If it does, write out the products and balance the equation. Okay, so you should have decided that iron is above copper in the reactivity series, so iron is more reactive. So this reaction will happen. Okay, so iron will displace copper from copper oxide. Now this is the part where you might have had a little bit of trouble, because you might have written that it gives you FeO, but as you see up here, that's not the formula for iron oxide. The formula for iron oxide is Fe2O3. All right, and that's going to be a solid, and then you should get your solid copper. All right, so the iron has displaced the copper to give me iron oxide and copper metal, and you can have a go now at balancing that equation. Okay, so we should have, we've got 1 iron, we've got 1 copper, 1 oxygen, we've got 2 irons and 3 oxygens, and we've just got our copper metal. Okay, so I've got 1, 2, 3 oxygens. Over here I've only got 1, so I'm going to need another 2 of these. Now I've got 1, 2, 3 coppers. I've only got 1 over here, so I'm going to need 2 more of those. And I've only got 1 iron over here, but I've got 2 here. So I need to add another one there. And that will be my balanced equation. 2, 3, 1, and 3. Okay, excellent.